To analyze a circuit that has both series and parallel capacitor connections within it, we're going to have to utilize our knowledge of both the series and parallel individually to be able to make smaller equivalent circuits and work our way down to one equivalent capacitor for the entire circuit. Now, as I've alluded to, we get a lot of mileage out of same color, same voltage. So I am going to start by just coloring in the voltages. So we have 10 volts up top here, 10 volts here, metal on metal on metal, 10 volts. Then we have our gap. So metal's no longer touching. I'm going to make that green. So we have a different voltage here on the bottom. And definitely not 0 volts, because 0 volts is the bottom of the battery. So all of this is metal touching metal. The fact that we come to forks in the road, junctions, as we're going to call them later on, doesn't matter. Same color, same voltage. Metal touching metal, same voltage. Now, for the 0 volts on the bottom, the blue, the negative terminal of the battery is always designated 0 volts. So same color, same voltage. So there we go. Metal, metal, metal touching. So we get 0 volts and 0 volts. So we don't know the actual voltage value of the green, but if we can calculate the voltage drop here, right, the delta V. So if we can calculate that delta V, then we can know the voltage of the green. Well, the thing you should look for is any capacitors that you immediately recognize, oh, these two are in series, these two are in parallel, and divide and conquer. Now, the other thing to look out for, and I think is oftentimes very, very helpful, is to start at the furthest point from the battery. So start on the left in this case. Start on left and work back to the battery. So I think that is often a helpful hint to consider. When we do that in this case, we can immediately see, I hope, that we have the 2 microfarad and the 4 microfarad in parallel because they have the same colors on the top, same voltage on the top, same voltage on the bottom. They are in parallel. So the first thing I did was to take 2 and 3 and make C23. Capacitors in parallel add, so that was very easy. The 2 plus the 4 equals the 6. So then I redraw the circuit, and I'm going to take my time here and do it with you completely. Same color, same voltage. We still have the green on the bottom of the first capacitor and the green on the top of our equivalent 2-3 capacitor, and of course the 0 down here. So same color, same voltage. Now, when we look at what we have left, they're in series because whatever flow of charge goes through the 3 microfarad capacitor, same flow of charge goes through the 6. So now, the 6, remember, is C23. So I have 1 on 3 plus 1 on 6 gives me 3 on 6. But remember, that's 1 on my equivalent capacitance. So we have a C123 of 6 on 3 or 2 microfarads. So now I know the voltage drop across my equivalent capacitance is 10 on the top, 0 on the bottom. And to find out everything about the initial circuit, in other words, the voltage drop across each capacitor, the charge on each capacitor, you are going to want to work your way backwards. So here we know we have a charge on our equivalent capacitance, right? Q equals CV. We have a charge of 20 microcoulombs. So you always want to solve the equivalent circuit completely, know everything about the equivalent circuit. So I know the charge on the equivalent circuit, the voltage is always the battery voltage, and we know the capacitance is the 2 microfarads. Well, when we now look backwards to the circuit that's above, we have capacitors in series. They have the same charge. So voila, now I know everything about the first capacitor, right? So we know the charge Q3 is 20 microcoulombs. We know that the charge on 2 and 3 together is 20 microcoulombs. Once I know the charge on 3, the 3 microfarad capacitor, I know the voltage drop across the 3 microfarad capacitor. So that first voltage drop has a 6.67 voltage drop. So that means we go from 10 to 3.33 because delta V here is 6.67 volts. So that means the green voltage is the 3.33 volts. And then we get a 3.33 volt voltage drop across both the 2 microfarad and the 4 microfarad capacitor. So now we know everything. Once we know the voltage across the 2 microfarad capacitor and the voltage drop across the 4 microfarad capacitor, we know the charge on each of them. So this is the basic idea. It takes a little bit of getting used to how to do these and practice working your way down, right, to get the equivalent circuit complete, and then working your way back up to most efficiently get the information on all of the capacitors. So again, I'll show you the complete page here. You can pause it, get the annotations that you need. We can talk about this, and you'll have practice circuits to work on as well.